there, it's Katie with TutorPUG. I'm going to do an example of how to calculate social gain at market equilibrium for Business Calculus 2. And I've made this particularly snarly because I wanted to expose you to all of the different possibilities that this kind of problem could throw at you. So first of all, we've got to calculate market equilibrium. And we need to understand the difference between equilibrium price and equilibrium point. So a problem could ask you for either one, and you need to know exactly what it is you're supposed to be reporting. So what the example that I came up with is a demand function that behaves this way, gives 1,000 bikes demanded when P is the price of a bike in $100. And my supply function says we will supply 0,000 bikes if the price falls below $8.9900, same units. If the market will sustain at least $8.9900, then they will supply that many 1,000 bikes. The first thing I need to do is find what is market equilibrium. Where is that equilibrium point or equilibrium price? So the first thing I'm going to do is set my demand function equal to my supply function, and I'll use either solver or graphing to calculate that to find out where these two intersect each other. And when I do that, I get that they intersect at a price of 9.96. So if these road bikes cost 9.96 $100, then we will have so many thousand bikes demanded. That would just be equilibrium price. If I also want equilibrium point, I will take this value and plug it back into either demand or supply, and that, because they're in equilibrium, so they're going to equal each other, so they'll intersect. So it doesn't matter where I plug this value in, it should spit out the same amount for each function. So I could go to my table, which is what I usually like to do, and I get that when price of a bike is $9.96 $100, then 6.54 thousand bikes will be demanded. And technically, at equilibrium, we use the subscript star or asterisk to indicate that we're talking specifically about the point when the market is in equilibrium, when supply and demand equal each other. So my equilibrium price, 9.96, my equilibrium point is 9.96, comma, 6.54. It's a point in space. So now I want to calculate the social gain at that market equilibrium. Recall that social gain is consumer surplus plus producer surplus. And think back, you have to use a little ingenuity and remember back to some of those former formulas. Consumer surplus is P naught to P max, anti-derive the demand function. Producer surplus is PS to P naught, anti-derive the supply function. So the part that I made snarly is I made the demand function be exponential decay, which means that his P max value will actually be infinity, and that means that I'm going to have to use improper integration on that. I went ahead and wrote out my setup so that I know exactly what I need where, and I plugged in the values for P naught, my equilibrium price, my P max, which is infinity because that's exponential decay, and my shutdown price, which is the easiest of the P soups to find. It's the one that's just right there in the function. Now, this is going to take the limit notation and the steps to find the improper integral, but this is something I can just pop through really quickly on my calculator with Math 9. So I'm going to do that and just write it over here so I have it for later, and I can then find my consumer surplus and plug it in and add them together, and that will give me my social gain. My social gain value is 3.18, and I'll come back, I'll figure out my consumer surplus and get that popped in there. To evaluate this, a review of improper integration, the first thing I have to do is say, I'm going to take the limit as n approaches infinity from 9.96 to n of this particular function. And now I'm going to actually anti-derive it. I have to keep my limit statement. So I anti-derive that. Over the natural log of 0.985, and I evaluate that between 9.96 and n. Take the n value and put it in where the exponent should be on the first go around, and I will put 9.96 up there, and that allows me to evaluate this limit. What I can do is I can put this statement into my calculator, and I can use an X for that variable and just make that get bigger and bigger. And I see that as this statement gets bigger and bigger and bigger, this shrinks down to 0. That's kind of what it's supposed to do in this example. So that means I now evaluate this value, and when I put 9.96 in for the variable, I get out negative 432.8. So that, negative 432.81, 0 minus a negative is a positive. So now my consumer surplus, after I go through the limit, so my social gain at market equilibrium overall is going to be, that's positive, 432.81 plus 3.18. Social gain is 435.99, and remember your units. I have 1,000 bikes times $100 per bike. So my units are going to be $100,000. 435.99, $100,000 is the social gain at market equilibrium. If this was not exponential decay, if this was linear or quadratic or cubic or even logarithmic, then you would, to find P max, which is the top of the integrand, recall that you would set this equal to 0 and solve for P, and that would give you the P max in that scenario. This is a long problem. It's not terribly difficult, but there are a few moving parts. So hopefully you have the intestinal fortitude to stick with it, and I hope you have a spectacular time working out these problems. Happy mathing!